Hi friends, in this video we are going to see the solved gate question paper for the year 2023 for CSE, and in this video particularly we cover data structure and algorithm questions, and it is a part 3 video. Let's move on to video. So here is your first question. Consider the C function FOO and the binary tree shown here, and the C function FOO is given here, and we have to find the result of this function. So the given C function is type def struct node interval struct node star left star right node. So this is the tree structure, and it is the structure of the tree having left and right child. And next, int FOO, this is the function FOO, foo node star p int return value, it returns the value if p equal to null. Here p is nothing but the root node, here it is 10. If p equal to null, we have to return 0, otherwise we have to perform this operation. Return value is equal to p value plus FOO of p left plus FOO of p right, and then we have to print the return value, then we return the return value. So this is the function, and this is the given tree structure. We have to apply this function, this program in this tree structure and find the values. Let's find the answer. So here the given is, in this tree structure, if the node is null, node has null value, it will return 0, otherwise it will perform this equation. So let's write this equation first. Return value is equal to p value plus FO of p left plus FO of p right, that is the root value plus its left function of its left value plus function of its right value. So this is the tree structure, and 10 is the p value first. First value is 10. Root node is 10, so we are applying the first value 10 in this function. So FO of 10 return value is equal to root value 10 plus its left child 5 plus its right child 11. Here we have to perform, we have to calculate the value of FO of 5 and then FO of 11 and apply in this equation, then only we can find the answer. So for finding this, we have so many like a function will be repeated like this, as we have the child nodes, further we have child nodes. So I just create a stack, and for easy performance I am just keeping this first function f of 10. This is the value we have to find for this function, and to find this we need FO of 5 and FO of 11. So first we have to perform 5 and then we have to perform 11. So I put in the stack 11 and then 5. Then I am going to find the value for FO of 5. For that, the 5 is not a null value, it have both left child and right child. So I am going to apply in the same equation. So it is 5 plus FO of 3 plus FO of 8. So here we have again two functions, FO of 3 and FO of 8. So I keep this in the stack. First we are going to perform 3 and then 8. So I keep f of 8 in the stack, then f of 3. Now I am going to evaluate f of 3. So for f of 3 we don't have child nodes, so the values are 0. The answer is 3. So once we find the answer for this equation, in the program it is given, you have to print the value and then return the value. So print 3. Now we have to find the value f of 8. It also don't have any child node. So the answer is 8, and it prints the value of 8 and it will return to its previous function. So here the previous function is f of 5. We have to apply these values in this function f of 5. Instead of f of 3 we are applying 3 and instead of f of 8 we have to apply 8. So we have found the values of f of 3 and f of 8. So we remove these functions from this chart. Now we are going to apply the values in f of 5 and 5. We have to find the f of 5. Top of the stack is f of 5. Now we have to find the f of 5. So f of 5 function, we are applying these values and we will get 16. So it will print the value and it will return this value to its previous function. Now we find the value of f of 5 is 16. So we remove this one. And we have to apply this value in f of 10. And for f of 10 we need f of 5 and f of 11. So we already find f of 5. Now we are going to find f of 11. For f of 11 we have one root node. So f of 11 is not a null value. So we apply this equation. It is 11 plus 0 plus its root value f of 13. And now we have one more function f of 13. I could keep it in the stack. And I am going to find the value for f of 13. It has no child. So the answer is 13. It will print the value 13 and then it will return it to its root function. So f of 13 is the value is sent to f of 11, and we are applying this value in this f of 11 and find the value for f of 11 is 11 plus 0 plus 30, 24. It will print 24 and then it will send this value to its root node f of 10. So applying these values f of 5 and f of 11 in f of 10, we will get 10 plus 16 plus 24. The answer is 50. It will print. So as per order, the output will be 3, 8, 16, then 13, 24 and 50. So this is the answer. It's just applying the function in this tree structure. First we have to find the value for 10. For this we need to find 5 and 11 values. For 5 we need to find f of 3 and f of 8, and we put these values in 5 and find f of 5. For f of 11 we need to find f of 3 and keep the answer in f of 11. We find f of 11 and both answers are sent to f of 10 and we find the answer for f of 10. So this is the answer. And the easiest question only if we apply the function perfectly in this tree structure. Next question. Consider a sequence A of elements A0 equal to 1, A1 equal to 5, A2 equal to 7, A3 equal to 8, A4 equal to 9 and A5 equal to 2. Here is the list of elements from A0 to A5. The following operations are performed on the stack S and QQ, both of which are initially empty. So we are having a stack S and QQ and we have to perform the following functions using these A values, list values. So first function is push the element of A from A0 to A5 in the order into S. So we are creating S using these elements. NQ the element of A from A0 to A5 in that order of Q. So here we are creating Q using the list A0 to A5. Now pop an element from S, that is deleting the element from S. DQ an element from Q, pop an element from S, DQ an element from Q, again DQ an element from Q and push that element into S. Repeat this step for 3 times. Then pop an element from S, pop an element from S, the top element of S. After executing all these above operations, you have to find. So this is also an easy question if we do step by step. So first one is push the elements of A from A0 to A5 in the order of the stack S. So we are creating a stack and pushing all the elements in the stack. So last in, first out. So 1 will go in the down, 5, 7, 8, 9, 2. Stack will be in this order. Next, NQ the element of A from A0 to A5 in the order into Q. So we are going to create Q with the same elements. In Q, first in, first out. So 1, 5, 7, 8, 9, 2 is the Q. Next, pop an element from S. We have to remove the topmost element from S. Topmost element is the last element 2. We are removing this. DQ an element from Q. Removing the first element from Q. First in, first out. So we are removing the first element. Answer is this. Remaining things. Then pop an element from S. Again we are popping the next topmost element 9. And the remaining will be the stack now. Again DQ an element from Q. So here again we are DQ. We are eliminating the first one. 5. The answer is 7, 8, 9, 2. Now DQ an element from Q and push that same element into S. So here we are going to delete the element from 7 from this Q and we are going to insert this 7 in S. So we are removing this 7 and we are keeping it in the stack. This is 7. So we have to, once we put in the stack, it will come to the top. This is the stack S now. Repeat the operation for 3 times. So we have to remove the next element 8 and keep it in this stack. Then 9 and keep it in the stack. 2 and keep it in the stack. So first we are inserting 8 and then we remove the 9, then keep it in the stack, it will come at the top. Then again we are removing 2 and we are keeping it in the top. Now pop an element from S, then pop an element from S. So here we are deleting 2 elements from S. Top 2 elements, first pop of S, then next pop of S. So again, pop an element from S. We are removing the topmost element 2, the remainder is this. And again pop an element from S. So we are removing 9 and remainder is this. This is the final step. Here the question is what is the top of the element of S after all these operations. So after all these operations we have the stack as 878751 and here the top element is 8. So the answer is 8. So this is also a simple question if we done perfectly using the steps one by one. With this, all the data structure questions for the year GATE 2 2023 is completed. For other questions in data structures, please subscribe my videos and you can find the other part 1 and part 2. Thank you for watching. Please subscribe. Thank you.